Hi everyone, thanks for joining our webinar today. We're just going to hang tight for a couple of minutes and give people time to join. We'll start at about 1:02 p.m. Eastern Time and 10 a.m. Pacific Time. Hi everyone, and thank you for joining us today for our webinar covering GraphQL at enterprise scale. I'm Julia Black, the events lead here at Apollo, and I'm excited to introduce to you Matt, the co-founder and VP of product at Apollo. Today, Matt will show you, among other things, how you can turn GraphQL into something real and useful at your company. Important to note, Matt will be answering questions at the end, so please ask away throughout the presentation via the question box, and we'll aim to answer as many questions as we can. And with that, I'll hand it over to you, Matt.
Thank you, Julia. Good morning, good afternoon, good evening, everyone. It's great to have all of you here today to talk about this exciting stuff. I'm the co-founder of Apollo, and over the last couple of years, I've had a chance to work with a lot of companies, not just adopting GraphQL to solve development challenges, but making a strategic commitment to the technology. And what I wanted to do today was talk through some of the lessons we've learned through the course of those conversations and the best practices that have emerged for how to build a GraphQL layer in the organization at scale and how to get the biggest benefits out of that. As Julia said, I hope to answer as many questions as we can throughout this, so please use the interface to do that, and we'll have time at the end to circle back. Let me start with just some context. I think it's helpful to have a perspective that we share on the problem we're really trying to solve and the challenges. So, it wasn't so long ago that an application was as simple as your web app and your mobile app talking to a backend. And this was the era, of course, of HTTP and REST as our point-to-point API technology of choice. As we've carried that model forward to present day, though, we run into some challenges and some limitations of that model. And I find this is the way that I understand GraphQL most clearly as a trend today. There's three things going on here, just to talk through them explicitly. So the first one is this proliferation of not just applications, but of the platforms those applications run on. So it's not just web and mobile, but a modern company today is building for potentially the watch, IoT, voice platforms. And within each of those, you don't have just one customer experience. You might have 3 or 4 different applications for either different segments of your customer base or for internal use or for your partners and so on. And so we've gone from a world where you had 1 or 2 applications to one where you potentially have dozens of digital experiences that each have to be world-class. And the data that those applications make use of, the actual information you want to put on the screen, that's also coming from a growing array of sources. The rise of microservices, of course, is part of this, but it's even more than that. You have data now scattered potentially in your cloud, in the public cloud on-prem. Organizations that are larger might be doing acquisitions, where as part of bringing a company into the picture, you're hoping to connect together some of the data that came from that company into the customer experiences you've already built. And of course, we have a rise of third-party APIs, cloud services, capabilities that aren't under your direct control, but still very much provide part of the data that's part of that customer experience for each of those apps. So those are the two obvious things that make it harder to use a point-to-point API technology to connect your applications to your data. There's actually a third that I think is really the keystone of the whole thing, and that's the emergence of legal, privacy, and security regulations that govern how all this data has to move around. In 2019, we are subject to GDPR. We're subject to laws coming from the state of California next year, and so on. And so the challenge of modern application development is really interesting to me, because what we're asking developers to do in the course of building great user experiences is to somehow navigate these increasing numbers of connections to each of the places data is coming from, and to do it in line with user expectations and frankly, legal expectations. And the problem becomes very hard to solve at scale. And so, of course, the solution and the reason why we're all here is GraphQL. GraphQL is that missing layer that cuts through the chaos of each of these point-to-point connections and replaces it with a principled mechanism for organizing all the data that needs to go to the clients and governing how that data flows. And the key idea here with GraphQL is that clients now declare in an explicit way the data that they require, and services declare in an explicit way the data that they can provide. That's GraphQL in a nutshell. And when we look at it this way, I think it's helpful to talk about a more specific idea than just GraphQL. GraphQL for a developer has a lot of advantages. It's got strong typing, less boilerplate code. You can use your network bandwidth more efficiently, but the bigger prize in this context, this conversation, is at the organization level. And so I find it helpful to think of this as a data graph. And we're gonna talk about this in the context of a single place in the organization that brings together all of the data and makes it available to every product engineer and product team right at their fingertips. And the advantages of this, and the reason I think we're seeing so much momentum rolling this out at scale in enterprise, are substantial. So the first one, of course, is that there's a lot less code to write. All of those point-to-point connections between every source of data and every application can be replaced with this. And that's code that developers don't usually enjoy writing. They signed up to build a great product experience, but what they're doing all day is they're writing this code that moves data from one place to the other. And it's code that doesn't help your app in any way. You have to have it, but it can only do something wrong if you make a security mistake or if you have a bug in something that hasn't been maintained. With GraphQL, you replace those with queries. It's much simpler. You have a consistent product experience is another big advantage of the data graph. So concerns that used to live in each individual application can actually move into the data graph itself. And that means your iOS app, your web app, and your watch app all share the same implementation, for example, of how localization might work or how you want to present a piece of computed data on the screen. And finally, and it's clear from this picture, I think, what you get is a central point of control and observation, not just at the transport level, but the actual meaning of your data is now consolidated into one place where you have this clear and precise understanding. All right, so that's the prize in my mind for the enterprise. Now there's some good news and some bad news, which is that it's happening very quickly. So let me start with the developer adoption. GraphQL has done very, very well over the last couple of years. Of course, that's why we're all here. And I think it's interesting to see this in contrast to a lot of the other attempts historically at providing a structured or organized set of APIs for products. We can see the obvious difference here over the last 18 months or so as GraphQL has taken off. And so the point here is the product engineers that we talk to have essentially said, we're never going back. The developer productivity benefits, the better tooling, the type safety and so on, these are things that are so valuable to us as product developers that we have no interest in returning to the days of handwriting our data fetching and state management code. So this one's here to stay in a way that was not true of some of the other attempts at solving this. And the other interesting thing happening with GraphQL is that your data graph ends up having a network effect inside the organization. It's very different from most of the technology that a product org might adopt. But with data graph, you have a prize for incremental adoption because each new application and each new service that joins this graph increases its value. So what we see time and again in organizations is not a bunch of disjoint uses of GraphQL, but rather a strong centralization trend from the very beginning. And that's really what brings us to today's topic, because the challenge you face is that you end up having very quickly a collaboration challenge and a scaling challenge because you're only going to end up with one data graph for the organization. And we see these questions time and again. How am I going to secure this thing when I've got my entire product org collaborating on it? How am I going to understand performance across a large data graph like this? How do I monitor it? What's the reliability story? I just spent 4 years trying to get away from a monolith. Am I bringing one back? And so these are the questions we see, and what we have found is a set of best practices or principles that allow teams to move forward successfully with GraphQL. And that's what I'd like to spend some time on with all of you today, walking through. So we're going to divide this into three categories, three ideas here. And the first one is around the integrity of your data graph. Think of these as the three critical architectural principles that set you on the right path for a scale adoption of GraphQL in the organization. And the principles are these. You should have one single data graph. You should federate the implementation of that data graph across multiple services rather than putting it all in one monolith. And you should have a separation of concerns where you track the schema or the menu of what's in that data graph in a central place that can be shared across the organization. So let me show you what that looks like architecturally. And this is what we have found time and again is the most successful way to roll this out at scale in larger settings. Remember, we're talking about a layer here. So this idea of a data graph is going to sit between your existing applications and your existing APIs and services and capabilities. And we're going to divide that layer into three parts. So the first part are what we have as connectors. And the role of the connectors is to implement your data graph. This is where the code that defines how we map your existing services and capabilities into a GraphQL schema might live, the resolvers, if you're familiar with the programming model. And the key idea here is that, first of all, you want these to sit on top of your services, not be part of them. That's an architectural principle we'll come back to at the end, but there's two reasons for this that I'll foreshadow. One of them is the adoption motion. By putting the data graph on top of your services, you avoid the challenge of having to get multiple teams to move at once. So this can be done entirely by your product engineering organization as a consumer of the APIs they're already using today. And the other benefit of separation here is a separation of concerns. And I'll circle back to that idea in a little bit when we talk about GraphQL native services. So the connectors each implement part of your data graph. And the orgs we've seen most successful with this have chosen an architecture where those are spread across multiple services. So you don't necessarily need one. You might have 3 or 4 as we show in this picture. And I'll talk about how to do that in just a second. The second layer on top of that is your gateway. So the key idea here is the gateway is doing 2 things. The first is it's the idea of composition or stitching. So we're gluing together the parts of the schema implemented by each of the connectors into a single graph. And the other role of the gateway is to centralize any graph level concerns. So for example, safe listing, an idea we'll talk about where we lock the graph down to known queries from your applications. This is something that can be implemented at the gateway level. And so what you end up with is a clean separation of concerns between the user code that implements your graph and the part that is shared infrastructure across all your teams. And then finally, we have our registry, a separate component that tracks the schema. Now, in a small scale deployment, you might use your GraphQL layer itself for this. GraphQL includes this idea of introspection, so you can get the schema from a running GraphQL server. But we found this doesn't work at scale in the enterprise. And there's a few reasons for this. First of all, you're going to want a history of your schema. So introspection doesn't let you understand how that's changed over time. It doesn't give you a collaboration point across your teams. Another issue is you're going to end up wanting to track multiple variants of your graph. So for example, you might have a staging environment or a feature development branch for your graph. And it's helpful to be able to ask what the schema is for that without having to have a running server in an environment that you can reach as a developer. Another issue here is you don't want to run introspection in production. Our point of view is that the data graph in production should be locked down and restricted to the apps that need it. The idea that you want to expose your entire schema, your entire menu of data to the public world doesn't really fit with that. And so you're going to need a separation of the idea of having access to the schema from the idea of a server that will answer a query. And as you'll see, there's some features we can build when the registry isn't just about what's in the schema, but also the analytics attached to that about how your schema is used. So this 2-layer architecture with an adjacent registry works really well in practice. And here's an example of what that looks like. So this is a large travel company that's adopted GraphQL strategically across the organization. This is their diagram, but you'll see a lot of parallels to the architecture that I just showed earlier. In this case, the individual services that implement the different parts of the graph are written in Java. You can really use any language for that. And then they're stitched together using a gateway, which is responsible, as I said, for answering queries and for the graph level concerns across of that. All of this is built on the existing services and the existing APIs in the organization. So the business logic, the security rules, the behavior that's been baked into these underlying services over decades of investment, that all remains the same. And the graph is a layer that sits on top of that simply to enable rapid product development across multiple platforms. So this has worked really well in practice, but there are some challenges. And one of the challenges that emerges at scale, especially as you go down this path of federating the graph across multiple services, is how you actually join them together into a single graph. The technology that people use today for the most part to do this is called schema stitching. It's an open source library that's part of the Apollo open source product. And the challenge of schema stitching is that you have to manually declare in the form of code how to bring together all these different services into one. That code lives in the gateway. It's fairly fragile to write, and it ends up being a collaboration choke point because we're back to the world where you have to write code inside your gateway if you want to change the structure of the graph. So to give you a preview of how this is changing and what we've learned from companies that are doing this, let's talk about an example schema for a moment, maybe with 3 different ideas in it. So if we have a schema like this that represents what you might see in a, say, e-commerce organization, we might have user accounts, and so we have a user type that reflects that. We might have product information, and we might have product reviews. And this is a pretty natural way to model all of that. here's the insight, and here's how I'd recommend you think about structuring your graph and how you divide it across multiple services. What you really want to do in some sense is organize this not by types, but by what we might call concerns. So for example, the product team is really responsible for understanding which purchases a given user has recently made. That isn't data that actually lives in the account service, it lives in the product service. And likewise, your reviews team, well, the reviews team might want to extend the product type with a set of reviews, but again, the code that implements all of that and the data that stores that review information is really not part of the product team or the product service at all, it's part of the review service. GraphQL has this idea of type extensions. So what we recommend and what we are releasing later this month as open source is a way to use this sort of a extension model to be able to break your overall graph into more logical concerns that look like what's on the screen here. And an example of what this looks like in terms of how you might define that schema is here. So in this new model, rather than stitching together imperatively, you might be able to extend a product type with an additional field, and you can define what underlying dependencies that has, and then write the resolver for that. So again, the model here and the key idea architecturally is to have your single graph implemented as a set of federated services and allow each team to own its subset of that graph. And we think going forward, the best way to do that is to do it in a logical fashion that separates by concerns using the programming model that I just described. So if you're interested in that direction, follow us on GitHub and stay tuned. That's coming out again, as I said, sometime toward the end of this month. All right, so the integrity principles help us understand architecturally the right way to structure the graph. The next set are about the workflows and the collaboration. And I think agility is a good way to frame this, because what we have found is the teams at scale that are rolling out GraphQL the best are teams that have adopted these concepts about doing it in an agile and high velocity way. There's a few things here, but by far the most important is the first one that's on the screen, which is to build a graph that reflects the needs of the product, or what we call a demand-oriented schema. And I would triple underline this particular one. In terms of an enterprise scale rollout of GraphQL, the most telling measure of success that we've seen time and again is the degree to which the definition of the data graph, the GraphQL schema, reflects the needs of the product engineering organization that consumes that schema. GraphQL was designed that way initially at Facebook, and the benefit of doing it this way is that you can use that separate layer, that data graph layer between your APIs and your app, as a way to translate your underlying APIs into something that reflects the needs of the product. And when you've done that, product development becomes very easy and natural, because the act of writing a new product experience is as simple as typing the natural query and navigating that menu of data that you have. What we see sometimes are teams that instead approach this more as a bottom-up or an API modeling exercise. And often what happens there is that the GraphQL schema more closely reflects the underlying API structure rather than reflecting the needs of the product. And what we find in that case is that teams often don't see the product development velocity benefits they were expecting to find, and it's because the act of consuming the graph isn't as natural and friction-free as it should be. And instead, developers are having to reshape the result of a query. They're having to navigate a surprising set of relationships or links between things. So the translation in terms of real world is make sure your product team is involved in the design of the schema. Make sure that the product team either does that work or has a strong voice in what lives in the schema and how that changes over time. And that'll set you up on a path for something that naturally spreads across the organization and that your adjacent teams are going to want to consume as well for their products. The other important idea here is to do it in an agile fashion. And this is a very big change in mindset from existing point-to-point APIs. So whereas with REST APIs, we think very carefully about versioning, and we recognize the high cost of changing the shape or the structure of a REST API over time, GraphQL really rewards a very different, more collaborative and more agile workflow where the schema is constantly changing. And to do that, you need good tooling. So I'll show you an example of what that looks like. One of our recommendations architecturally is to validate potential changes to a graph against the known use cases of that data graph. And here's an example of what that can look like. So GraphQL has some interesting capabilities, and all the parts of it work together here. So clients are explicitly defining their requirements in the form of a query. So we have a precise understanding of exactly what data a client needs and how it's going to use it. GraphQL is strongly typed and it's structured. So when we see a GraphQL query over the wire, we have a precise understanding of exactly what data came back, what fields were used. And because it's statically typed, we have a way to check these for compatibility in a structured way that isn't possible with REST. So the way this works is as a proposed change to the data graph, say changing an input type or removing a field that we don't think is used, is presented, what we can actually do is statically replay all of the known uses of the data graph that we've observed historically against that proposed change. And this is a static computation. You don't need a running implementation of the graph to do this. This can all be done in the context of your CI workflow. So a best practice architecturally is what we call schema change validation, which is every time one of your teams wants to make a change to the graph, that's a natural part of the development process wired into your source control system and validated against uses of the graph, even distant uses that the team isn't aware of. And doing that allows you to have this workflow where teams can confidently move forward, much as they can confidently move forward because of their unit tests for their own code. They can confidently move forward with rapid changes to the graph structure without fear that they've broken a use case that they don't know about. And what that enables is something really powerful, which is the fact that changes to the graph are no big deal. And that means you can develop a product-centric architecture. You can do it very quickly, almost speculatively as part of your application development process. You can roll that out into production. And if you find over time that that wasn't the right product feature, or that wasn't the right way to think about the way you want to show data on the screen to a user, or you find something else that you want to change about that experience, you have a very lightweight way of doing that. So you've taken the old style of APIs where every change is such a big deal that you want to play it conservatively, and you move to a very different regime where the API can flow with the needs of the product in a much more agile fashion. So that's an example of bringing this metadata about how the graph is used into the registry of what the schema for the graph is. And that's a powerful concept. Here's another place we can use that. And another principle of agile development is to bring this data into the developer workflow and put it at the fingertips of product developers. So what we're looking at here is a typical developer working on a GraphQL query inside their editor. And what we'll see here is because GraphQL is strongly typed and because we have this interesting metadata about how the graph is used, developers can move much faster by having all this information at their fingertips. What we're seeing here, for example, is a GraphQL developer, as they're typing a query, understands not just what fields are available and what input types are required, but also the predicted performance of the query as they type it. They can see information about fields and how those fields might change over time. So for example, if you're working on an application and you move to the feature development branch for a product, you immediately see that you have some deprecated fields in your query, and you see immediately the structured information that's part of the GraphQL schema about the right way to rename that use and to move to the correct name of the graph. So here's an example again of that agile graph development process enabled by having not just the schema, but also all of the metadata about how the data graph is used wired into the full development process. Okay, that's agility. Finally, we have a set of principles around operating the graph in production. And these are some of the hard-won lessons based on people's experience with rolling this out at scale. So for example, one thing I mentioned earlier is the idea of a safe list. The idea is you don't want a graph API that anyone can issue an arbitrary query to. What you actually want to do is on a client-by-client basis, grant specific access to the data graph based on the queries that that client wants to run. A pattern we like to see in production is one where, as part of continuous delivery of client code, the queries that the client uses are registered and the server only accepts those queries in production. So this idea is you lock down that data graph. You have the agile development process where you can write an arbitrary query, but in production, you are back to a structured access pattern where you're only answering queries that were written by a trusted member of the team. The idea of structured logging sits underneath everything we've talked about. It's what makes it possible, for example, to do schema change validation. And for organizations that are using observability systems, open tracing and the like, the idea here is to bring in as much structured detail about the data graph as possible into those systems. Rather than just having the idea that a client ran a query, you have the idea that a client accessed the following fields with the following costs. And so wiring that up is a helpful way to bring these ideas into your existing strategies for application performance monitoring, for observability, for security and auditing, and so forth. And finally, I want to circle back to that point I mentioned earlier in terms of the separation of concerns. So we believe that the best way to bring data graph into an organization is to layer it on top of the APIs that exist today. And there's a couple reasons for doing that. As I mentioned, one of them is it makes it faster to adopt, and you don't have to make this into an org-wide commitment on the first day. But the other reason is that the data graph separate from your services gives you, in some sense, the best of both worlds. Your service APIs are really designed to have a very specific behavior. And any great API team is going to want to have a really clear understanding of what are the expectations in terms of reliability, availability, predicted performance, and so forth of their API. That's much easier to do when the API for the service is fixed and it has a small surface area with a limited scope of responsibility. And so the idea here is that data graph actually rewards the use of finer grained APIs and microservices that have small orthogonal endpoints. And so that's why we recommend the separation of concerns. Now, if you are building a service from scratch and you know that it will only be used in the context of a data graph, in other words, that's the only way you're going to query it, then it may be reasonable to bring in something like a GraphQL native service where you can implement that service with just a GraphQL API. And you don't need this idea of a separate connector that maps the underlying data structure into your data graph. And that's a good pattern. So the key here is when we talk about services, it's all about the capabilities, the business logic, all of the implementation that you've invested in over the previous years of the organization, all getting leveraged into the graph and keeping those two ideas apart. Okay, so finally, just a word on Apollo and how this all fits together. Apollo is an implementation of GraphQL that's designed for what we've been talking about. It's designed for building a data graph that's going to live on top of your existing APIs. And so just to help orient you as you start looking at some of the specifics of what's out there, I wanted to show just a quick look at what those parts look like. The core of Apollo is a set of open source libraries that implement consumption of the graph. That's Apollo Client, which lets you bind your UI to your query, and Apollo Server, which is what implements that graph, those implementing services or connectors that we saw before, as well as your gateway that brings them all together. And then what we sit next to that is a set of graph management and graph analytics services that implement the sort of registries and workflows that we talked about before. And so this is available in a variety of configurations depending on the scale and the needs of what you have. But the key idea here of a two-layered GraphQL structure in your environment coupled with a cloud registry and set of workflows maps again to what we've seen organization use successfully as they've rolled out. And finally, just some ideas for the future. There's much more detail on the principles that I went through at principledgraphql.com, as well as in the documentation for the Apollo tools. If you'd like to know more, we're running a number of events in the coming weeks and months in New York City and in San Francisco, where you'll see examples of companies that have implemented architectures like these, lessons learned, things that have worked well, things that have worked less well, areas of investment for the future. So I encourage you to join us for those. And please reach out if you're interested in learning more about any of what you've heard about, either on email or on Spectrum, and we're happy to help. So thank you, and let's see if we can shift to the Q&A part of this and answer some of your questions. All right, let me pull up what's come in while we've been talking. Okay, we have quite a few here. Give me a moment. Let me see if I can get a sense of how these tie together. Okay. All right, so we have a couple questions here around access control and security. One of them reads, in regards to access to the graph, have you seen successful models of access control that limit access to certain parts of the graph for certain clients? What do those look like? That's a really great question. And I mentioned one of those, which is safe listing. The way we think about safe listing is like this. As you're developing your client, we have a precise understanding of exactly what queries the client's going to issue. And so Apollo includes some tooling for extracting those queries from the client source code, registering them with an operation registry that lives in the cloud, and then from that operation registry, building a manifest of permitted operations that gets loaded into your GraphQL gateway for execution. I think of that as sort of the fundamental or primitive that you can build on top of. So the immediate consequence of doing that is you've restricted unexpected uses of your data graph, but you can go much further. So for example, you might have multiple client teams in your organization and you want to restrict access so that some clients can access subsets of your graph and others have maybe a wider purview of what they can collect. One tool for doing that is to put a review or an approval step as part of that registration workflow. So you can enforce constraints on which clients can see which parts of the graph or query which parts of the graph at development time as you roll that out. The other direction you can take this, and this is something that's on our roadmap, is to actually restrict the schema for a certain type of client. And one way you might think about that is a common architectural pattern we see is teams will actually have two versions or two flavors of their data graph schema, one of them for privileged internal use and one of them for external use. And so that first one might be more of an admin schema that has some fields that really aren't intended for end user usage, but that are important internally for diagnostics or for building privileged dashboards and the like. So that's a good pattern that we like. The implementation of that today requires some code. So you're going to actually write the code that filters down your admin-only schema or composes in admin-only fields into a second schema. I think in the future, though, there's a lot of room to do that more declaratively. And so we're interested, and this is something I think will emerge as part of the GraphQL standard conversation over the next year as well, of how do you have a standard way of declaring as part of your schema that a field is or is not intended to be used by a certain class of clients. Let's see. We have a question about comparisons between Relay and Apollo client, the pros and cons of each. For those who aren't familiar, Relay is a GraphQL client used by the team at Facebook. Both Relay and Apollo client are GraphQL standards compatible. So you can absolutely use Relay as a consumer of a data graph, just as you can use Apollo client. I'd say the objective of Apollo client is to have a friction-free, very easy to adopt programming model for the modern React team. And we really built Apollo client with that use case in mind. So it's designed to slot in very nicely with not just React and how the component model works, but also how people think about state management in the application, how people think about caching and some of the other considerations that are part of building a rich client experience. Relay takes a heavier weight approach. Relay is more of a framework that you structure your whole application around. And so it puts many more demands on the overall structure of that app. It's certainly not optimized for the transition of an existing Relay app that you've built into a GraphQL compatible library, and instead it focuses on some of the performance considerations that you get when you have more of a heavier weight framework, and some of the structure ideas around how you can identify different parts of your GraphQL schema with primary keys or whatnot. But they're both standards compliant. They both work across the organization. I will say, if you look on NPM, for example, Apollo client has emerged as the near ubiquitous choice among React developers, and I think that's largely just because we've oriented specifically around the needs of the teams that are building these sorts of apps and want to move over to a data graph as the way that they're going to query the data. There's a question about events and queues compared to Kafka and RabbitMQ. I think that's a really interesting question. So, if I go back for a moment to the architecture that we talked about, forgive me while I get there. There's a lot of different things you can plug into a data graph. So the services here that I talked about, typically we might see connectors query those services over REST or in a organization that's moving to Thrift or gRPC. Those are excellent choices. But there's another model where services can push data into the graph. And so I think the integration idea here is you might have an event bus. You might have some source of asynchronous events that you want to wire into your data graph. And that's very easy to do. Think of the connector not just as something that can query a fixed API with a request response pattern, but also as something that maps an event from a message bus like Kafka into a part of the schema. There is some support in Apollo for GraphQL subscriptions. So subscriptions allow you to carry that event model forward all the way to the client, and the client can actually subscribe to the result of a GraphQL query whose results may change over time. And so the other use case for a message bus like Kafka is to drive recomputation or requerying. So for example, if you have a GraphQL query that returns real-time inventory status or real-time product reviews, you might use your message bus as the invalidation bus that causes your GraphQL layer to refetch the correct data from the underlying service with a Thrift or gRPC or REST API. There's a question about error handling. This is, in all candor, a part of the GraphQL standard that I think needs a lot more work and needs a lot more structure to it. So I'll speak at a high level about errors. In a REST API, typically your API call either succeeds or fails. So we have an HTTP status code, and of course we can build clients around that. With GraphQL, it's more nuanced because GraphQL actually has the concept of a field level error or a resolver level error. And what that means is you might do a query and get back a mix of successful results, but also missing data because of an error underlying the system. I think that's a really interesting and powerful programming model. For example, just staying on this screen, if one of the connectors or one of its underlying services fails, you may actually want the rest of the query to return to the degree that it can. And that creates some really nice patterns. If you're building an e-commerce store, product availability information may be critical, but customer reviews may be something that you can build with a lower reliability standard. And so if the developer can type a query that seamlessly brings together product information with user recommendation information, but in cases where the recommendation system isn't available, just returns the key product information and the screen can render that accordingly, that's a really nice development pattern. But unfortunately, there isn't that same structure to GraphQL errors that we have in HTTP. So for example, a common challenge is how do I distinguish an error that's really like a client-side error, like a 300 class error in HTTP or a 400 class error from something that's really a server error like a 500 class error. There is some work being done on this, both at the GraphQL standards level and inside Apollo's implementation. And it's something that I expect we'll see some progress on over the coming months. For now, the best practice we recommend is you can write code in your GraphQL gateway that annotates or transforms some of those errors. And what we recommend is having a consistent point of view across your org about whether you're going to use strings or integers or how you want to use GraphQL's flexible error structure to have something that you can use consistently across your product. Okay, some questions about composition and stitching. How do you run a gateway locally with many services without running each service, only running the needed services for development? That's a really great question, and I'll skip over to this for just a moment. One of the things we've thought about a lot as we've worked on the newer composition model that I mentioned earlier is exactly this question. For example, if I look at that middle column, the product service, if you look closely and think about it as a standalone GraphQL schema, the problem is that there's no definition of the base user type here. And so we want a structure that lets us run that service in isolation in development or for testing, where we don't have to have a running user service next to it to make that whole thing complete. And if you extend that concept, you might want to do partial combinations. So you might want to be able to, as a developer, take some of the services that are used in production to implement part of your graph and then join those together with a service that you have under development. So the answer to the question of how you do this is going to be really specific to the way that this implementation works. I'll just say that this is a key workflow that we think is really critical. As I said, somewhere toward the end of the month as this rolls out, look for some specific guidance on exactly how that'll work. We have a question on dynamic data in GraphQL, like JSON or eJSON scalars. the real life scenario for this, writes the questioner, is for allowing the client to pass in custom filters. Thoughts on this? Yeah, there are some people doing something like this. One of the basic ideas in GraphQL is your schema is static. So having a dynamic set of fields is difficult, but writing a query where part of the input variable is a query string or some sort of application specific filter on that data is very workable. I think the strength of GraphQL in part is that it doesn't really take a position on the meaning of a query or the meaning of an argument. Don't feel like you're constrained to passing arguments that are just like simple strings or enums for your GraphQL data. You can actually do some fairly flexible things with that. Again, I think the key thing to do is to understand in an organization as you're scaling, how are you going to have a consistent way of structuring your data graph across multiple teams? How are you going to have a group of people that enforce a common standard across those ideas? And so long as you have some consistency to this approach, I think that can work really well. Let's see here. I know we're running short on time. Let me see if we have maybe one more question here that several people have touched on. Well, there's a quick, how did you get autocomplete in your IDE? Is there a plugin you use? What you saw on the screen earlier was a plugin for VS Code, and so that's part of the Microsoft VS Code store. If you just search for Apollo or GraphQL, you'll find that. And that's based on a common open source implementation we call a language server. So creating similar plugins for other editors is a pretty simple integration exercise. And finally, there was a question here about protobufs and whether Apollo server can talk to protobufs. Yes, absolutely. I think that's a great architectural pattern. And the key idea here is inside Apollo, we have an abstraction called a data source. And so there are data sources for talking to REST or GraphQL endpoints. You can also do the same for gRPC or protobufs. Or Thrift. In fact, an architecture we see a lot recently is one where the underlying services speak Thrift, and then the connectors are a fairly simple and thin translation of those Thrift payloads into the subset of the schema that they're responsible for. And finally, one more question, and then we'll call it a wrap, is around caching. I think this is a really interesting topic. So the question is about how do you manage caching between schemas or across stitching or composition? One of the things that we can do, because we have this structured understanding of the data, is we can start to have some really sophisticated policies around things like liveness and caching for that. And so Apollo includes a standard extension to the schema definition that allows you to specify a cache policy at the field level for a GraphQL result. And there is a limitation today that doesn't work with schema stitching because you have to handwrite all the code to bring that together, but it does work with the composition model I just described. And so what that allows you to do is for example, partial query caching, where in a schema like we have on the screen, you might be happy to have long TTLs for some of the information with respect to users or products, but your reviews in your inventory service might want a 0 TTL or a much lower number. And there are a number of organizations that are using that in production today, where incoming GraphQL queries are often able to be satisfied partially from cache inside the Apollo server. And so the underlying fetches to the APIs can be minimized just to those parts of the result that need to be refreshed as part of each query. So that's a great pattern. We recommend that. And partial query caching, ultimately I think is an example of how this really structured and fine-grained understanding of your data enables some patterns that weren't really possible in a point-to-point REST API world where each API call is fairly opaque. All right, let's wrap up there. And again, thank you everyone for joining. We're happy to answer questions further, and have a pleasant day.